Hello, and thanks for joining the WebEx. My name's Mary Napolitano, and I'm the product manager for LinacView, which is an effortless quality assurance tool to be used for every fraction of every treatment. And here are some of my colleagues at Standard Imaging. And so I'd like to go through a bit of housekeeping before we begin. Today's webinar is being recorded for future review, and at any time you can enter questions in the GoToMeeting dialog box, and they will be addressed at the end of the webinar. Standard Imaging is based in Middleton, Wisconsin, and was founded in 1989, and Standard Imaging designs and manufactures a full suite of QA products for radiation therapy. And this picture was taken a few weeks ago. We've had some unseasonably warm weather, and you can actually see the grass in most places at this time. And so let's begin. So first I'll go through the LinacView workflow. So of course, you would begin by creating your plan in your treatment planning system. Once that's complete, you would export your RT plan from the TPS through to your record and verify system for delivery, and as well at the same time export to the LinacView console. After the plan is delivered, you can either do this in pre-treatment or, of course, with your multiple fractions during your normal patient treatment. And the LinacView will be monitoring through a syncing system for the log files of the Linac. And so since the RT plan has already been exported and imported into the system, when log files are received from the Linac, those will automatically associate and be analyzed. So you can do pre-treatment QA analysis or during treatment QA comparisons between the log and plan files, as well as reference to log file 1, for example. LinacView can generate audible or email alerts based on some tolerances that I'll talk about in a bit more detail in the webinar going forward. And then as a final step, once your fraction is delivered or any of your sessions are delivered, you can create an RT plan either based on a particular log file session or as a summary of the entire composite delivery. And then you can feed that back into your treatment planning system and compare that against your initial RT plan. So when you first acquire LinacView and after it's set up and installed, the administrator for your system will need to spend some time going through and reviewing all of the setup options, of which there are numerous ones. You can begin with the default, but everything is customizable, and individuals like that quite a bit. So with the custom templates, you can set when you will get alerts and failures so that you will know what tolerances, and you can modify the tolerances for different delivery types. You can set these alerts and tolerances on your jaw position, carriage positions, your monitor units, your gantry angle, your collimator angle, and your table positions. And then based on the RT plan fluence map calculation and the log file fluence map calculation, you can do some fluence map comparisons based on the gamma, chi, or delta index comparisons. And in order to use those comparisons, you of course can set your tolerances there as well, your thresholds, if you want a global or local gamma, as well as if you would say like 3% 3 millimeter, 2% 2 millimeter, it's all user modifiable. As well, you have the option to review the plan complexity And for LinacView, it's a modulation complexity score, the MCS, as you'll see it designated in the software. And a value of 1 is a highly complex plan, while a value of 0 is non-complex. And we'll look for that when I walk through the software. And this modulation complexity score is based on both the leaf sequence variability and the aperture area variability. So both are combined to the modulation complexity score. And as well in the custom templates, and I'm just listing a few of the things that are customizable, are the notification options. So the user can set up to have an audible alert coming from the LinacView computer if it's perhaps sitting in the console area, if any of the failure tolerances are exceeded. Or one can set it up so that the physicist will receive email notifications based on his alert preference levels. There are customizable reports that are generated automatically at the end of each treatment session. And there are also RT plan export options. For example, one can export the RT plan with the number of control points in the original RT plan at every specified number of degrees. For example, for a VMAP plan, if you want your control points for your RT plan to be at every 2 degrees or every 4 degrees, you can set that option. Or you can create an RT plan using every control point from the delivery. But most treatment planning systems will not allow you to import RT plans that have that many control points, but it is an option. There are numerous users that can be set up within the system, from the very basic user that is just for monitoring to more detailed analysis to users that can modify and adjust all of these custom templates. But you can certainly set up users with any and various sorts of access to the modifications within the system. So one of the really nice features of LinacView is that once it's set up and operational, no user interaction is required for all of the analysis to occur. So the log files are being monitored at all times, and you do get alerts from the system if at any time that monitoring is interrupted for any reason. And so you have your this is a representation of the LinacView computer, and you have all of the Linacs at your site busily delivering plans, and all the time the monitoring is going on and these log files are being taken in by LinacView and analyzed. And then this picture shows a particular Linac has a tolerance that has been exceeded. And so if you have it set up for an audible alert, all of a sudden you would be hearing alert, alert, or it would be playing whatever music you have designated for the audible alert. But if there are no alerts or failures, then the system would be just monitoring day by day, and when one comes through, then you could take action, or on a periodic basis, the physicist or whoever has the rights to go in and look at all the detailed analysis could do so. And so mostly there are 2 types of QA that can be reviewed using the LinacView software. On the one side, there is the clinically relevant review, which is based on the fluence comparisons between the RT plan and the log file, as well as the plan-specific parameters that are logged for each patient plan. And then this is meant for immediate action to ensure that the treatment delivery is appropriate. And so, of course, alerts are sent if any of the action limits are exceeded. But then on the other hand, if you want to just go in on a periodic basis, you can review the general machine parameters and review the carriage, leaf, jaw, table, monitor unit rates, and go in and look retrospectively for, say, a particular type, your head and necks, and you just want it to go in and see how close to the plan your Linac is delivering, and see if there's a particular leaf that seems to be getting close to tolerance or failure. In addition, I previously stated that you can create summary RT plans. So, for example, in this particular plan, you look at log file 1 and 2 all the way down to log file N, and you can average the beams and then send this average of all of your beams back to your treatment planning system. So release 3.6 came out in mid-January, and I just wanted to go over with you the two key new features. The first is that the log plot files from plans delivered on Elekta Linacs using AFS will now associate correctly with the RT plans. And since I know people like to deliver using this automatic field sequencing, that is enjoyed by the users. And then we have also included Elekta Unity support. And so in case you want to know why is LinacView so useful for the Unity support, it's because the Unity has a true adaptive workflow, and this limits your pre-treatment plan QA options because the plan is optimized and created while the patient is on the table. So then each fraction is like a new plan. And the physicist is only able to measure after the patient treatment is complete. And so in this case, the LinacView software can give indication typically before the patient has even left the room, the quality of the treatment compared to the planned treatment, the delivered versus the planned. And of course, since this is a new system, independent QA is desired as it's a new workflow using a new platform. And so now I'm going to go and provide a brief software demo, but I want to give you some background about where we're beginning from. So at this point in time, one will assume that the RT plan has been exported from the treatment planning system to LinacView, and it's also been exported to the record and verify system. And I'm going to go ahead and copy some log files into the system so that we can simulate the delivery options now. And so let me bring the software up first. And of course, I have a warning because I'm not really connected to a Linac. And so it warns the individuals that the log file syncing has gone down, and customers choose to have this be a key service that is monitored by their IT so that one is notified right away if that logging synchronization service has lost connectivity. And so since I'm not connected to a Linac, my syncing is lost. And this is the LinacView software. And this is the dashboard. So right now you can see LinacView is not analyzing or bringing in any log files, but I can go ahead and copy some log files in. And then we can watch how quickly LinacView analyzes 5 days worth of treatment sessions. So this would be like delivering 5 different plans. And so you can see on these different dates, there was an alert. I'm logged in as an advanced user now. And so you can see both the selection as well as all analyzed parameters. And so if you want to just hover in this area and then go on into a particular session, you can take a look at the parameters that have caused the alert. So I'll go ahead and select a particular day, and I will load that session. And it brings us right into the summary page. And everything is color-coded, and so you can see the parameters that met the pass criteria that was previously set up is in green. So the monitor unit passed, the fluence comparison passed. The gantry, though, is in orange, so that means an alert limit has been exceeded, but nothing's in red because red is your failure limit. The collimators and the beam off lags are all in green. And then as well, this same color coding goes throughout the summary page, and you can see your tolerances. Those are in the orange or rust color and red, but all of the values are in green for the jaw settings, and you're just looking at the tolerances over here. So if these are off by more than 0.5 or 0.8 millimeters, for example, the RMS error is 0.5 and a failure would be 0.6, but you can see we're close in several regions, but have not exceeded the area for the alert. And then this is the area where the monitor unit is reviewed and the gantry. And you can see right here, the maximum gantry deviation was 0.5 degrees. And that's what caused our alert for this plan. We can go ahead and click on the gantry tab. And you can see at the beginning of the delivery control point, 1 or 2, there's one position that is out of the set alert. We can look through the monitor units, and you can see RT plan control point versus the monitor unit deviation in % of total monitor unit. And you can, of course, compare the monitor unit with multiple different graphic options, and you can display the log control points as well, or the RT plan control points. We can look at some fluence comparisons, and what we're looking at here is on the left side, this is the planned fluence calculation result, and it's based on the RT plan JAWS, RT plan MLC, and RT plan monitor unit. And then on the right is the delivered fluence based on the log file jaw positions, MLC, and monitor unit. And then stepping back up to the top, we can see a histogram as well as the gamma map comparison for a gamma 2%, 2 millimeters with a cutoff of 10%. And in this case, we have 100% pass rate. And you can see the histogram variation of the gamma results as well. We already stepped through the gantry and then the collimator. Again, you can show the collimator angle with gantry angle, with gantry speed, with monitor unit, and monitor unit rate. So you have a lot of different graphical display if you want to go in and look. And another area you can go through and look at many variations for the jaw positions and the carriage as well as the leaves. And you can look at the leaves, you can look in individual banks, And so if you look in an individual bank, you can even scroll through and look at each leaf position. So this is showing on the left side down here, showing your leaf position deviation for leaf pair number 20, and as a function of the RT plan control point. And then this graph in the lower right is showing the RT plan control point versus the leaf position in millimeters, and it's the expected in black and the delivered in red. So you can see there's very good agreement, and you can flip through all of your leaves. So if you think you're having a problem with a particular leaf, you can certainly open this up and take a look, planned versus expected versus delivered for any of your leaves. And then if you want to switch to your opposing bank, do the same for the opposing bank and flip through all of your leaf positions. So there's some pretty powerful tools for you to go in and investigate your delivered plan versus your expected plan delivery. Or if you want to look in a different way, you can look at the RMS error of all the leaves, leaf pair versus RMS error, or the maximum variation in the leaf pair. And there are just a couple of leaves that have a maximum above the 2 millimeter deviation that was specified. Of course, you can set your alert and failures at any level you would like to for your clinic. The next area that I would like to show is the dynamic view. And so in this area, before I start the playback, when I start the playback, the radiation sign will go on when the area in the log file is started where radiation is being delivered, and it will show the gantry and the collimator angles in this area. And right now, 0% of the total monitor unit has been delivered. And I typically like to go ahead and look synchronized as percent of total monitor unit, but you can look and synchronize on with control points. And you can see here that there's a nice tooltip just in case you're not sure what partial with sync of CPs means. There's a lot of nice text associated and a lot of nice tooltips associated with the different options throughout the software. And I just wanted to point that out before I start playing. And I'll go ahead and start playing this plan. And you can watch, this is the log file control points. We're at about 100 out of 1600 plus, and the RT plan control points of around 20 out of 177. And up here on the left, this is the log file is what's being shown. And then on the right is the fluence plan comparison based on 2% 2 millimeter between the RT plan fluence and the log file fluence, and it's moving at a rate based on the percent of the total monitor unit. So you can see it's updating at a slower frequency than you can see the leaf movement. And at any time you see a red or a orangish rust color shown on the leaves, it's telling you that a leaf is in the alert zone. So to have been more interesting, I could have set my tolerances quite a bit tighter and we could have seen some alerts and failures, but you saw a few flash through. And then at any time you can actually, if there is a failure, you can cursor over these leaves and look at the specific positions. As I'm showing, it's showing the leaf is too closed, too open. It's showing the exact leaf position as well as the variation, the deviation from the plan. And so you can, cursor through at any time and see that information as well. And then along the bottom, we were just seeing a gantry speed, degrees per second. And then in the fuchsia is monitor unit rate, percent total monitor units per second. And so let's see, what else should I show you? Oh, yes. So for every plan, I mentioned the modulation complexity score. It's shown in much of the UI, and for this particular plan, the modulation complexity score is 0.345. So that's pretty reasonable, because 0 is a not too complex plan, whereas 1 is a highly complex plan. And so you can monitor that, and some users might even want to determine if they would like to perform a measurement for a per patient plan if the modulation complexity score is too high. So that's another thing to think about. And I believe that covers most items I would like to show you in the software. I'm logged in right now as an advanced user, but I don't have access as this user to show you all of the settings and the analysis opportunities, but those are in under an admin sort of user. And so I'll go back to our PowerPoint presentation. And so in summary, LinacView performs real-time log file monitoring for every patient without impact on the patient workflow. So it's happening behind the scenes and producing alerts based on the clinic-specific tolerance levels that have been set up in the software. The therapist can see dashboard results in real time during treatment. The physicist receives automatic email alerts for significant issues based on how they have set up their tolerances and desire to receive email alerts. Automatic machine performance analysis is done for each fraction of every patient. And overall, it's easy IMRT VMAT QA fluence comparison. So at this time, I will check in the chat box to see if we have any questions. And if you have a question, I will give you a few moments to put something in the chat box. And I don't see any questions. Okay, well, thank you very much for your time. And I appreciate your attendance. If you have additional questions going forward, just reach out to Standard Imaging and we can get those questions answered. Have a good day. Thanks very much.